Hello, folks. Welcome to Science Talk. I am your host, Jim Massa. In this video segment, I want to address um, an issue that climate deniers always bring forth to deny human involvement in changing the climate, namely that it's the sun. Okay? So, as you can see here, pull this up from the Skeptical Science, and they do some decent work over there debunking a lot of misconceptions, shall we say. And the summary is right up here. Sun and climate moving in opposite directions. Now I'm going to, you can pull this up. I'll probably leave the URL in the description box, but there are three levels of explanation here. I'm going to focus on the intermediate one. The basic is, well, basic, and the advanced, it has a lot of complicated mathematics, which in my view is not necessary to get the point across in this video. If you go to the website and you, on your own, you want to look at the mathematics, by all means, go for it. So I'm going to look at intermediate, and then I'm going to pull up another paper that's mentioned in here, and we'll further discuss what's going on. So we'll start with the myth. It's the sun. Over the past few hundred years, there's been a steady increase in the numbers of sunspots at the time when Earth has been getting warmer. The data suggests solar activity is influencing the global climate, causing the world to get warmer. That's the misinformation, disinformation, whatever term you want to use. That's the misconception that is put forth. In the last 35 years of global warming, the sun has shown a slight cooling trend. Sun and climate have been going in opposite directions. Okay, so let's get into it. This first graphic is very important, but a little background. Okay, we know that the sun is the supplier of almost all the energy, almost. Doesn't account for, say, the energy at hydrothermal vents in the deep ocean, as an example. Okay. The sun has strong influence on climate. A comparison of the sun and climate over the past 1,150 years found temperatures closely match solar activity. That's according to Usoskin of 2005. However, after 1975, temperatures rose while solar activity showed little to no long-term trend. This led the study to conclude during these last 30 years, the solar total irradiance, that's STI, okay, solar UV irradiance and cosmic ray flux has not shown any significant trend, so that at least this most recent warming episode must have another source. And what could that other source be? Anthropogenic burning of fossil fuels. Just like when I did my Milankovitch videos, I did two videos on it. I did a very lengthy one explaining what Milankovitch was. You had the eccentricity changes over like 100,000 years. You had the switch in the North Pole, basically the wobble on its axis, and that's about a 23,000 year cycle. Then you had the precession of the solstices and equinoxes. It's about a 40,000 year cycle. And I explained how that influences the energy coming into the planet, how that affects the climate, and that hypothesis was brought forth to try and explain onset of ice ages and the receding of the ice sheets and so forth. But it doesn't explain everything. I did a second video where I said that Milankovitch does not explain everything, and what it doesn't explain is what's been happening in the last 150 or so years, namely human effects on the climate. So Milankovitch occurs on the timescales of thousands, tens of thousands of years. We've got a 23,000, 40,000, 100,000 year cycle. We're talking 150 years. So Milankovitch, the signal, it cannot detect any such subtle signal. It's just not sensitive enough. Well, this study is basically also showing that there's another factor going on, and that's human activity. So let's look at this graph here. Okay, so this is total solar irradiance measured in watts per square meter. Okay, that's what the scale is here. This is watts per square meter. We're going back to 1880, and up to 2020. So as you can see, the data goes to about 2010 or so. And then we have the temperature change here on this side. And this is in degrees Celsius. So cooling down from -1 all the way up to +1. If you look at the lightly colored red line, that's yearly temperature. So we expect to see some variation because of a thing called seasons, winter, summer, etc. The bold-faced line is the average. And as we can see, there's a little dip down in the early part of the 20th century, a steady rise up until basically the end of World War II or start of the 1950s, so a little cooling down. And then from 1970 or so, whammo, it's just skyrocketing. It's increasing dramatically. It's going from about, say, 0.1, 0.15 change to almost 1 degree C. Okay? That's for the entire planet. Total solar irradiance. The light blue line is, again, yearly results. And you can see it cycles about the 11 years sunspot cycle. But when you look at the total, the solar irradiance, okay, up until here, about 1950 or so, it seems to be somewhat correlated. Not perfect, but somewhat correlated. But look at how it has decreased dramatically from the start of the 21st century, in essence. It's gone down while temperatures go up. So if you try to use this to explain the warming, the correlation, the R squared would be a poor results. So obviously, sunspot activity, solar output, energy output is not the explanation. Okay, so what else can we say? So this is, here's a description with the figure we just looked at. Annual global temperature change with an 11-year moving average. Okay, I've explained to you before how moving averages, how they're done. So the same idea. The temperature from various sources, NASA, GISS, TSI is total solar irradiance with 11-year moving average, and then that's the dark TSI. And this is from Krivova et al. In 2007, the data from there. Now, Foster and Ramstorff, and I'm going to be discussing their paper in a little more detail later on, use multiple linear regression to quantify and remove the effects of ENSO, El Nino Southern Oscillation, as well as solar and volcanic activity from the surface and lower troposphere temperature data. They found that from 79 to 2010, solar activity had a very slight cooling effect of between minus 0.014 and minus 0.023 degrees C per decade, depending on the data set. That's Table 1 and Figure 2. So Table 1, now MEI. MEI stands for Multivariate ENSO Index. We already know what TSI is. AOD is basically the aerosol optical density due to volcanic activity. That's what AOD stands for. So in other words, how much effect the volcanic material, that's, volcanoes erupt, they throw material in the atmosphere. What is the effect of those material thrown into the atmosphere have on temperature? That's basically what that is measuring. Let's first look at the MEI, okay? A reminder, if it's in the positive, that's pretty much an El Nino situation. If it's in the negative, that is a La Nina situation. And if it's within these first hash marks here, or half a hash mark, that's pretty much a neutral situation, neither El Nino, neither La Nina. So here we basically have a strong El Nino, bunch of El Nino, extremely strong El Ninos, and so on. This is a very strong La Nina. Now, the data doesn't go back, but if you went back to the mid-70s, there was a very strong La Nina here. And we had a couple La Nina's event. That was a particularly, noteworthy La Nina coming out of La Nina now. as we go into later years. This La Nina was about 88, 89. This is when Alaska was in a really nasty cold snap. So what this is showing is, okay, we're removing those effects, and the aerosol optical density, you notice it really only dips down apparently when there's an El Nino taking place, as in here and here. Otherwise, not much going on. And then here's your total solar irradiance, and we again see the trend of a declining trend. Now, usually when there's an El Nino, you have like warmer situations for certain sections of the Pacific and North American side of things. We're not really seeing much of a correlation between TSI and the MEI. Really not. And if anything, might be a slight lag here. This looks like it slightly precedes here. Not a very strong correlation. So like Foster and Ramstorff, Lean and Ryan in 2008 performed a multiple linear regression on the temperature data and found that while solar activity can count for about 11% of the global warming from 89 to 2006, it can only account for 1.6% of the warming from 55 to 2005, had a slight cooling effect from 79 to 2005. Okay, this 11% is actually very generous. I've seen papers where it's actually more about 7%. So in other words, what they're saying here is that if we accept their value, 11%, what they're saying is that the solar activity is accounting for 11% of the variation or the response seen in the temperature. When you look at most of the papers, 7%, that is really not a driving factor. That is not a significant contributor to the response that is observed. That's what that bottom line message is. Solar activity is not a significant contributor to what is observed. Plain and simple. Full stop. And then it's even further less when you look at this particular time frame. It's almost basically negligible. In fact, it is negligible, to be blunt. So now we look at this solar contribution to global warming according to peer-reviewed science. Okay, so the percent contribution to global warming for the past 100 and 150 years, and then for the past 50 to 65 years, and they're citing several studies here. And what you're basically seeing is that the highest one is the SO7. That's basically 38% or so. The LRO8 is down to about 15%. That's when you're looking overall for 150 years. But when you look in more recent analyses, it's even less. So this conclusion is confirmed by many studies finding that while the sun contributed to warming in the early 20th century, it has had little contribution, most likely negative, in the last few decades. And there is a citation here of all the various papers that they looked at. Okay? And basically giving you a synopsis of the findings. Here's Lean, the paper that was cited. According to this analysis, solar forcing contributed negligible long-term warming in the past 25 years, 10% of the warming in the past 100 years. Lockwood, 2008. The conclusions of our previous paper that solar forcing has declined over the past 20 years while surface air temperatures have continued to rise are shown to apply to the full range of potential time constants for the climate response to the variations in the solar forcings. Okay, translation. Sun ain't doing anything. That's basically what it is. That's the translation. And it said they've listed this, pretty much a whole bunch of papers here. So the graph to look at is this one. That's the graph to look at. That tells you, in a nutshell, that's the contribution of the sun in driving Earth's temperature is negligible. Or if it is not negligible, it is an extremely minor player, but it's basically negligible. So I want to now pop over to this paper. Okay, let me pull this up. Foster and Ramstorff measured the global warming signal. It's a 2011 paper. Okay. They published a paper in Environmental Research Letters seeking to extract human-caused global warming signal from the global surface temperature and lower troposphere temperature data. In order to accomplish this goal, the authors effectively filtered out the effects of solar activity, ENSO, and volcanic activity. The result is shown in Figure 1 below. Okay, so temperature anomaly, basically deviation from average. And, well, what do we got here? It continues to rise. If you were to fit a regression line right through here, it has a very positive slope, right? Very positive slope. Now, granted, we're talking about 0.3 degrees C, and that's over basically the last, this is for a 30-year period. It is more so when you include the last decade. But this shows the trend. This shows the trend of the temperature still continues to rise, even after adjusting for those other parameters. Foster and Ramstorff characterized ENSO by using the multivariate ENSO index, that's the MEI that I referred to, aerosol optical thickness data, the AOD for volcanic activity, and solar irradiance data to characterize solar activity. They also tried using the Southern Oscillation Index, SOI, data for ENSO. SOI tends not to be as strong it's not, let's put it this way, MEI is a more reliable measure than SOI is. There's some issues with the SOI. It doesn't seem to be as accurate, or it seems to have more error associated with it. MEI is a bit stronger. Now, a reminder, I did a series of videos discussing oscillatory systems of planet Earth, including ENSO. Please check it out. I discuss a lot of things about that. So please check that out, as well as all my other ones, the PDO, the Indian Ocean Dipole, the Arctic Oscillation, the Arctic Dipole, North Atlantic Oscillation, Atlantic, et cetera, et cetera. They're all there. There's about 7, 8 videos, including rotational systems video. So they're all there. Go check them out, please, if you haven't done so, or watch them again. So they approximate the influence of these exogenous factors by using multiple regression of MEI, AOD, PMOD on temperature data from these various sources. Since these exogenous factors can have a delayed effect on temperatures, they tested lag values from 0 to 24 months to see which best fit the data, and the results are listed in the table. And basically, what they're showing is that the MEI, AOD, and the TSI are what they looked at. So the degrees C per decade for 79 to 2010, so that's basically a 31-year period, the lag in months for each of the 5 temperature records in each of the 3 exogenous factors. Numbers in parentheses are standard errors in the final digits of the estimated values. Okay, so this is a raw, and then they did an adjustment, and these are the standard errors. Basically, your plus or minus. So filtering out these external effects increased the 32-year warming trend in every data set except UAH. This analysis reveals that the underlying human-caused global warming trend in the surface temperature data ranges between basically 0.2 and, it differs by 5 thousandths of a degree C per decade, and between 0.014 and 0.016, if you round, per decade in the 2 main satellite lower troposphere temperature data sets. This is a similar result to Huber and Nudi in 2011, who estimated approximately 100% of the observed surface warming since the 50s have been caused by human effects. This corresponds to approximately a 0.55 degrees C warming, most of which has occurred since mid-1970 for 0.15 to 0.2 degrees C per decade, anthropogenic warming based on the Huber and Nudi results. Additionally, we see that the lag before ENSO is reflected in surface temperature is 2 to 4 months, 5 to 7 months for volcanic effects, 1 month for changes in solar activity. In the lower troposphere, so that's higher up, the lags are 5 to 6, and 0 months respectively. So the authors conclude, when the fluctuations in temperature over the last 32 years, which tend to obscure the continuation of the global warming trend, are accounted for, it becomes obvious that there has not been any cessation or even any slowing of global warming over the last decade or at any time during this time span. In other words, any deviations from an unchanging linear warming trend are explained by the influence of ENSO volcanoes and solar variability. It is worthy of note that for all 5 adjusted data sets, 2009 and 2010 are the 2 hottest years on record. Okay, keep in mind, these papers came out in 2011. We have since even had hotter years since then. And here's that graph that we looked at earlier. It's basically showing what's going on here. And again, there's that trend that there's the raw data, and then there's the when you remove, right? So let's pull this up here. Okay, this is the raw data. This is when you remove these signals out of it. We still see the warming trend. You understand what this is showing? This is the raw data. You can still fit a regression line, but then we remove those signals, bang, look at that. That's a definite warming trend. Okay, here, those peaks here, when it comes back, and that's a strong El Nino event. That's a strong La Nina event. So they're accounting for these natural variabilities. That's the natural variability included. You remove it, and what are you left with? The anthropogenic signal, which shows a clear warming trend. That's what this is showing. Now, I said, this is from a paper, about 10 years ago. Okay, here's your adjusted data sets. Clear warming trend. This is basically averaging. Okay, this is the average of the 5 adjusted data sets. So now taking all the data sets into account after accounting for the natural stuff, and so volcanic activities, solar irradiance, and the trend is very unmistakable. So the authors conclude by averaging all the data sets together, because the effects of volcanic eruption and of ENSO are very short term, and that of solar variability very small, none of these factors can be expected to exert a significant influence on the continuation of global warming over the coming decades. The close agreement between all 5 adjusted data sets suggests that it is meaningful to average them in order to produce a composite record of planetary warming. Figure 3 shows the true global warming signal. That's this guy. Okay? Now, these are the 5 data sets, and you can see how they're in very close agreement. So, based on this average of all 5 adjusted data sets, the warming trend has not slowed significantly in recent years, and they conclude the resultant data set clearly show both visually and when subjected to statistical analysis that the rate of global warming due to other factors, most likely these are exclusively anthropogenic, has been remarkably steady during the 32 years from 79 through 2010. There is no indication of any slowdown or acceleration of global warming beyond the variability induced by these known natural factors. Well, in the intervening decade, we are seeing an acceleration of global warming. Now, you can't fault them for not concluding that because the data set didn't indicate that to them. But I have not been able to find a recent paper by them. I think one of them might have retired or whatever. But it would be interesting to see, their updated analysis. But the point of doing this video is, to address those folks who say it's the sun. And this data clearly shows that it's not the sun. And also, they went further in removing or accounting for natural variability afforded by natural things such as ENSO, volcanic activity, and other factors. When you account for the natural variability, you're still left with a warming trend, which means what's left is human activity. So what's the take-home message from all of this? Take-home message is simply that solar energy has no influence on the warming, nor does ENSO or any other natural variability, nor does volcanic activity. When you account for all that, the contribution to the observed changes is not significant, and what you're left with is human activity. They're showing a nice linear up until about 2010 or so, 2011. In the decades since, we've seen a further warming increase. So it will probably still be either a higher slope to the linear regression or perhaps moving more towards an exponential rise. So there you have it. The sun is not a factor. It's not a major contributor at all. When you account for natural variability, we're still left with an increase in the temperature, which is due to human activity. Plain and simple. There is the science. I thank you for your time. I hope you found this informative. And if someone brings this up to you around the water cooler, you can basically say, bollocks. So until next time, talk soon. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.